A Telebyte video.
Welcome to a demonstration of IEEE 802.3 CG 10BASE-T1L compliance testing using 1.0 volts peak-to-peak and test mode 1. This will feature Analog Devices Evaluation Board and Ethernet PHY evaluation software with Telebyte's digital analyzer, probe, and software. This demonstration will show you how to identify problems, analyze transmit signal output voltage and timing jitter, perform repeatable testing, see clear pass-fail results, and produce printed reports with graphs. The equipment and software in this demonstration includes Analog Devices eval ADIN 1110EBZ EVM evaluation board, Analog Devices Ethernet PHY evaluation software, Telebyte's 4975 digital analyzer and software, as well as Telebyte's 4975 P01 probe for signal capture. This setup can test with 1.0 volts peak-to-peak and 2.4 volts peak-to-peak. It can also test with test modes 1, 2, or 3. Let's take a look at the devices and software we'll be working with today. In the bottom left-hand corner, we have our Analog Devices Evaluation Board. This board receives its control and power via a USB connection that goes to the Telebyte 4975 digital analyzer, which is loaded with Telebyte's 500 software, as well as Analog Devices Ethernet PHY evaluation software. The evaluation board is also connected to the Telebyte 4975 P01 probe via an adapter cable from a 3-terminal SPE screw connector to an RJ45 connector. The probe also has a 100 ohm termination on the front, and from the back it is connected to the digital capture card that is installed in the digital analyzer. In order to enable USB power on the ADI evaluation board, do the following. At P5, connect a USB cable. At P4, jumper pins 3 and 4. Next, we need to connect the probe to the 4975 digitizer card. This is done by using an SMA to SMB cable, which is connected to the digitizer card and also to the back of the 4975 P01 probe. Then we need to set the attenuation to 0 dB. This is accomplished by manually sliding the red switch on the probe to 0 dB. Let's take a look at the software in action.
Hello, today we're going to use the Analog Devices ADIN 1110 EBC evaluation board to do some IEEE 802.3 CG compliance testing. The first thing we want to do is put the Analog Devices evaluation board into the test mode 1 signal. So I have my notes here how to do that. Using the 1110, we use a PHY write command. So PHY writes and reads to certain registers that are in a hex value with certain values. So I have a program here that's using Termite, and I'm connected to COM13 here at 115,200 bits per second, 8 bits, no parity, and no handshaking. So I have a connection to the device here, and I will write to the registers to put the Analog Devices ADIN 1110 into a test mode 1 signal. And test mode 1 is used for jitter analysis, jitter timing, and also transmit output voltage level and short-term variation as well. PHY write. Power the device up. So I'm using Termite here. That's a serial connection to the analog devices evaluation board. I also have the Telebyte 500 series software open, and we can open up the spectrum analyzer view, and I can see here that it's looks familiar to a test mode 1 signal where we're sending positive ones and negative ones, and this is the test mode signal. It's using PAM3 level pulse amplitude modulation, and this is the frequency domain view of the signal. So what we want to do in our noise, our signal capture software, we call it the 500 series software, we want to take a 2-second capture. And I've got the sample rate at 500 million samples a second. We have channel 1 on with AC coupling, and we're using 100 ohm load impedance. The digitizer is set to a plus or minus 2.5 volt range, and I'm using a 0 dB value for the attenuation. So I'm going to hit start here, and we're going to overwrite this signal here, ADIN 1110 test mode 1 volt peak to peak. So you can see we just captured 2 seconds of the file, and I can analyze this signal. It's going to analyze just this portion of the signal between my red cursors there. So the first thing I notice is the peak to peak value. It's about 0.5 volts here and negative 0.5 volts. So we're in the 1 volt peak to peak operating mode. Then I can zoom in by drawing a rectangle around the signal. And I want to make sure that the signal looks like what I'm expecting. So I see plus ones and negative ones here on the signal. The time scale here is times 10 to the minus fourth here. So we're looking at the test mode 1 signal here. And then I can perform the jitter analysis on channel 1. So we have the time domain view, the frequency domain view, and then the amplitude probability density function for statistics on the signal. And then we'll look at the eye diagram here for the jitter analysis. So what we see here is the amplitude of the eye is 1.028 volts. The height of the eye is 1.026 volts. It's a wide opening eye, so I know I have a good SNR value. The width of the eye is 130.5 nanoseconds. The SNR is 63.1 dB. Then we have rise and fall times of 32.5 nanoseconds. It does look very symmetrical. And then we have the clock frequency at 7.499891 megahertz. And our peak to peak jitter is 2 nanoseconds. And this is the value we're looking for it to be less than 10 nanoseconds for a passing value, and then we have our RMS jitter of 0.9 nanoseconds. So this is the jitter analysis kind of manually running this test. We also have a test report here that we can generate. So I can run in, we have 10BASE-T1L, IEEE 802.3CG standards, or also the Ethernet Advanced Physical Layer Test report. So we have an analog devices board here, and it's the ADIN 1110 EBC. And right now we have the operating mode 1 volt peak to peak, and I want to load the 2-second capture that we created just now, and then I'm going to generate a report. And what this will do is generate a PDF report for test mode 1 and give me a pass and fail criteria. There we go. It opened up the Adobe Acrobat Reader, and here's the 10BASE-T1L test report. So if I scroll through this, we have a table of contents with the different tests listed in 802.3CG. And here's our test information, the software of the 500 series software, the standard revision that we're using for pass and fail criteria, the 802.3CG-2019. There's our digitizer and our card serial number for the digitizer, and then the information we entered on our device under test, and then a date and timestamp. So you can see the output voltage in the 1 volt peak to peak mode must be between 0.850 volts and 1.05 volts, and we measured 1.04, so that is a pass. And then we have the transmitter timing jitter. You can see in the 1 volt mode, it must be 10 nanoseconds or less, and we measured 2 nanoseconds, so that's passing. Then we get a histogram, the transmit clock histogram, And the period is 133.3 nanoseconds for 10BASE-T1L, and you can see we're measuring 132 and 134 nanoseconds. So we're right in the middle of those two values. And then we have the transmit clock frequency. So we measured 7.499884 megahertz, and we must be between 7.499625 megahertz and 7.500375 megahertz. So that's a pass. And then we also looked at the short-term variation. That's within about 2 seconds. If there's any variation of the clock, and we're not seeing, the variation must be equal or less than 0.1 p part per million per second, and we're measuring 0. So we passed the short-term variation test. And that's the automated report then based on our manual testing.
Thank you for watching this demonstration today. Here are other videos that you'll find in this series.
We would be happy to provide you with more information. Please go to telebyte-SPE.com to learn more, or you can send an email using sales@telebyte-SPE.com.